Alright, so our next problem has to do with drawing an ellipse. And even though I know your math teachers don't agree with this terminology, we said that the area of an ellipse is equal to pi times, that's an ugly looking pi, hold on. Pi times r1 times r2 for the radius. I know it's actually the major and the minor axis and half of that, but this is the exact same equation as the area of a circle, just knowing that we have two different radii. So that's kind of cool. So the area is pi times r1 times r2. It shows us over here somewhere that this is the minor axis. And we're trying to figure out what the major axis would be. Solve for the major axis. And it gives us a couple of points that we have to consider. Now, for some reason, I always see students making something little like this, and you should know right away that this would be wrong because your minor axis cannot be bigger than your major axis. This is our major axis here. All right, well, so let's back up a couple steps. We know not to do that. So we have the minor axis, and we're trying to figure out what the major axis would look like. So let's go back to this. They tell us the ellipse has an area of 4.71 is equal to pi times our radius 1, our minor axis. Our minor axis is 2, but the radius is from the center going out, right? So that would be 1 times r2. And again, r stands for radius. That's from the center going out somewhere. All right, so r2 is equal to 4.71 all over pi. And if you check your calculator, 4.71 divided by pi gives you about 1.5. All right, now each grid is 0.25. 0.25 goes into 1.5 6 times, so 6 quarters and $1.50. So we're going to count out. There's 1, 2, 3, 4, 5, 6 grids. And 1, 2, 3, 4, 5, 6 grids over here. And we make our ellipse. That's going to line up with those 2 points. And should look something kind of like that. There we go. Perfect.